Now let's take a look at prime factorization. So when you write a whole number, it's just a multiplication problem of prime numbers. We call that the prime factorization of a number. And so looking at 300, you can kind of see it written using nothing but prime numbers. And all those numbers are prime because the only factors they have are 1 in themselves. In the second example, it's not correct because 1 is not a prime number. To be a prime number, you have to have 2 different factors, and in this case, the only factor of 1 is just 1. In the third example, it's not a correct prime factorization because 6 is not prime. It's composite. In other words, 1 and 6 are not the only factors of 6. It has other factors. So now that we know what prime factorization looks like, let's go into the process of finding it. So the 2 easiest ways to find prime factorization is to use factor trees or factor tables. Now I'll be going through these examples fairly quickly, but if you want further details on how to make a factor tree or factor table, I'll put links in the description. So let's start by finding the prime factorization of 126 using factor trees. So since 126 is not a prime number, we have to branch out using a times table. I'll just use 2 times 63. 2 is a prime number, so that branch will stop. 63 is not prime, so we have to branch out with a times table. We'll just say 9 times 7. 9 is not prime, so we have to branch that out with a times table. We can use 3 times 3. 7 is prime, so that branch will stop. Now since 3 is a prime number, both of those branches at the bottom will stop, so now your factor tree is done. Once your factor tree is finished, the prime factorization is found by just multiplying the prime numbers on your tree. So the prime factorization of 126 is 2 times 3 times 3 times 7, which is the same thing as 2 to the first times 3 to the second times 7 to the first power. All right, now we're going to find the prime factorization of 126 using factor tables. So what I'm going to do is put 126, make a little L box, and then we have to divide by prime numbers until it gets all the way down to 1. So I know 2 is prime, and it goes into 126, and 2 goes into 126, 63 times. Now I need a prime number that goes into 63. We can use 7, and 7 goes into 63, 9 times. Now I need a prime number that goes into 9. We can use 3, and 3 goes into 9, 3 times. And now I need a prime number that goes into 3, and we can use 3. 3 goes into 3, 1 time. And so now we're all the way down to 1, and the factor table is now done. Once again, you can find the prime factorization by multiplying all the numbers on the left side of the factor table. And so the prime factorization of 126 is going to be 2 times 3 times 3 times 7, which using exponents is 2 to the first times 3 to the second times 7 to the first. The same answer we got with factor trees. So now let's get into the prime factorization of 13. Now as far as a factor tree, we already have a problem. We only branch out if the number is not prime. But since 13 is already a prime number, the branch is going to stop. So the factor tree of 13 is just simply itself. Let's make a factor table for this number. Do 13 and do an L box. So we're going to divide by prime numbers until it gets down to 1. Well, the only prime number that goes into it is 13. And 13 goes into 13 1 time. And since we're already down to 1, the table stops. So this brings up an important point. The prime factorization of a prime number is just simply going to be itself. Now that we're done, you can do something more useful with your time, like have a picnic. But if you see 2 bears that ain't Yogi and Boo Boo, you'd better run. Like and share Math on the Fly. Laters.